This video is about symmetrical property of a unit circle. Suppose this is the theta, and this angle theta on the unit circle, that's R1. The coordinate on the unit circle is P and Q. We know on the unit circle, the coordinate is C as T, cosine, sine, and tangent. For tangent equals sine over cosine. Therefore, we can write down Q over P. Then for this unit circle, we have the following facts. P equals cosine theta. Q equals sine theta. And Q over P, that is tangent theta. Since we know sine squared theta plus cosine squared theta equals 1, therefore we have P squared plus Q squared equals 1. Suppose this angle is theta. Then we can form this rectangle. Then we can label the point on the unit circle. This is R2. This is R3. Here is R4. According to the symmetrical property, we can get the coordinate for each point on this unit circle. For R2, you will get a negative P, Q, and a Q over negative P, that is negative Q over P. For R3, you will get a negative P, negative Q, and a Q over P. For R4, you will get P, negative Q, and negative Q over P. For the coordinate on this unit circle, we know this is a C as T. This is a C as T. C as T. Let's talk about quadrantal angles on this unit circle. We have 0 degree or 0 or 2 pi or 360 degree. For this angle, that is 90 degree or pi over 2. For this one, we know this is pi or 180 degree. This one is 270 degree or 3 pi over 2. For the coordinate of quadrantal angles, we do know this is a 0. Here is undefined. This is a 0. This one is undefined. Let's talk about the angle for R1 to R4. This is a theta degree. This one, we will write down 180 degree minus theta. Or we can write down pi minus theta. For R3, we will write down 180 degree plus theta or pi plus theta. For R4, you can write down 360 degree minus theta or 2 pi minus theta. Or we can write down negative theta. Negative theta for R4. This is very important. According to this diagram, we can figure out some trig reduction formula. For example, sine pi plus theta. Pi plus theta is this line, that's R3. This is a CST. So sine pi plus theta equals negative Q. Negative Q, Q is sine theta. Therefore, you will get negative sine theta. For cosine 2 pi minus theta, it's R4. CST, cosine, you will get P. P is a cosine theta. So you get the cosine 2 pi minus theta equals cosine theta. For tangent pi minus theta, that's R2. Tangent is negative Q over P. Negative Q over P. Q over P, that's a tangent theta. Negative Q over P, we can write down negative tangent theta. For cosine negative theta, it's R4. That equals to P. P is a cosine theta. It's here. Sine negative theta, that is a negative Q. Negative Q equals negative sine theta. For tangent negative theta, that is a negative Q over P. So you get the negative tangent theta. We call this three formula. It's a trig even odd formula. Let's learn more about symmetrical property of a unit circle. We know this is a theta, and the point on the unit circle is R1. So we have PQ, Q over P as a CST, and this is the fact. Let's assume this is a theta and this is a theta. So we have C1, C2, C3, and C4. We can form a rectangle if we connect this C1, C2, C3, C4. And we assume this angle is a beta. So we know this theta plus beta equals 90 degrees. In other words, theta and beta are complementary angles. That's the reason we use C to show those points. And you could say R1 and C1 is reflecting across the line y equals x. Since we know when 2 points are reflecting across y equals x, then the coordinate will be switched. Therefore, for C1, you will have a QP. Then the tangent will be P over Q. Then according to the symmetrical property, we can figure out the coordinate for C2. It will be negative Q, P, and negative P over Q. For C3, you will get negative Q, negative P, and P over Q. For C4, you will get Q, negative P, and negative P over Q. And also we know Q over P equals tangent theta, then P over Q. That equals cotangent theta. Then we can label the angle for C1, C2, C3, and C4. For C1, we can label as a 90 degree minus theta, or pi over 2 minus theta. For C2, we can label as 90 degree plus theta, or pi over 2 plus theta. For C3, we can label as a 270 degree minus theta, or 3 pi over 2 minus theta. For C4, that is a 270 degree plus theta, or 3 pi over 2 plus theta. Let's use this diagram to figure out the following trig reduction formula. Cosine pi over 2 minus theta, that is this line. Angle will be beta. CST, which means this is a Q. So cosine pi over 2 minus theta equals Q. Q is sine theta. Sine pi over 2 minus theta will be equals to P. P is a cosine theta. Then for tangent, pi over 2 minus theta equals P over Q. P over Q equals cotangent theta. For secant, that is 1 over cosine. You will get cosecant theta. And for cosecant theta, that's a reciprocal of sine. Then you can get secant theta. Cotangent theta pi over 2 minus theta will be tangent theta. We call all these 6 identities is cofunction identities. For more examples, cosine pi over 2 plus theta. Pi over 2 plus theta is this one, negative Q. Negative Q, that is negative sine theta. For tangent, pi over 2 minus theta, that is P over Q. P over Q, that is cotangent theta. Sine 3 pi over 2 plus theta, that's this line. Sine will be negative P. So we can write down negative cosine theta. For tangent, 3 pi over 2 minus theta is this one. Tangent will be P over Q. So P over Q, which means cotangent theta.